This lesson serves as a reminder to you, in case you've forgotten, about how to fit a trend line to data and to make forecasts from the trend line. And we have done that before. So that is our learning intention. Can you fit a trend line to deseasonalized data and make forecasts? And notice there it says deseasonalized data, which is what we studied in the last lesson. So these are the steps following on from the last lesson. If you've got some seasonal data, you have to first of all calculate your seasonal indices and then deseasonalize the data. And then what we're doing here, calculating the trend line equation. Use that equation to make predictions. And the last step, which is often forgotten, is that you actually have to re-seasonalize your prediction to get an actual prediction. So as I said, this lesson is just about reminding you how to fit a trend line and use it to make predictions. So here is some data. It hasn't got any seasonality in it, it's just year by year. It hasn't been deseasonalized is what I mean by that. So we've got number of government schools in Victoria over a 12-year period. What we want is a gradient and an intercept of the line of best fit, or the least squares trend line, as we prefer to call it. And then we will want to make a prediction for the future. By the way, I've put a little thought bubble there, how to lie with statistics, because if you look at that graph, you will think that the number of government schools in Victoria is declining fairly rapidly over that period, but in fact it doesn't, as you will see shortly. Anyway, you need your graphics calculator. Stat edit. Now we're doing annual data, so although we have data ranging from 1980 thereabouts, you actually have to put 1 to 12 in your L1 column, and then the numbers corresponding to the years in L2. To make the graph, second function stat plot will lead you to the second diagram on my page here. Make sure it is on for plot 1 and that you've selected the second of the two types which are available. Also make sure that it's showing L1 and L2. And if you press zoom 9, you'll get a graph that is similar to, but not exactly the same as, the one in the textbook. As I said, we can lie with statistics. If you want to put something more realistic in, then what you actually would do is to change the range of the vertical axis. I suggest something more realistic, like a minimum of 1,000 schools and up to 2,200, which you do by pressing Window and then changing Y min and Y max as I've done here. If you do that, you will see a graph more like that when you press Window. In other words, it's not declining as fast as you would think. Anyway, that's how not to lie with statistics. On my second image on this page is where we want to get the equation of the straight line, which we do with stat calc 4 linreg, which stands for linear regression. So select 4 there, press enter, and you'll see the equation of the straight line. It has a gradient of minus 12.5 and it has a y-intercept of 2169. By the way, you notice I didn't put diagnostics on. That's because we are not doing r and r squared. And that's it for getting the trend line. Now let's make a prediction. So this is out of the textbook. They want to say how many government schools are predicted to be in 2015. Well, use your equation, y equals mx plus b, so the number of predictions will be 2169 minus 12.5 times 35, because 2015 will be 35 years from 1981. Notice also it says at the bottom, this is involving extrapolation, which if you remember from earlier units is well beyond the range of the given data and so should be treated with caution. Who knows, a number of government schools might come under some new government policy and go up, not down. That was data which was not deseasonalized. So we're looking at another example here where the data has been deseasonalized. So all the work that you did in the last exercise has been done for you. I think this is the one that we worked on anyway. This is Mickey's shop. So those are the deseasonalized figures that we arrived at with Mickey's shop. Trend line is calculated in the way that I just showed you. Each quarter is another 1 on the horizontal axis. Now, Once we've got the equation, we see that Mickey's sales are going up by 32 per quarter. Well, that's fair enough. Now let's make a prediction. We want to know what the sales might be in the winter of year 4. Now, on the basis of the numbering system that we use there, winter in year 4 will be the 15th item. Put that into the equation and we get a deseasonalized prediction of 1319.5. That is not what will be the sales figure predicted for winter in the 4th year. We actually have to multiply that number by the seasonal index for winter, which was 1.3, and that will give us a predicted figure of 1715. That's how you make a trend line to deseasonalized data and to make forecasts.